Hello, back to biology class, and gonna start with a little review before we go on talking about atoms and molecules and all that good stuff. So in the background, here's the periodic table. Remember, this side over here are the metals, nonmetals, noble gases, metalloids, transition metals, okay? Hydrogen's not a metal, but it's over here for more than one reason. It helps to balance the table, but also because it has one electron at its highest energy level. This is group number one, and actually all of these elements, and they get bigger as you go down with more energy levels, but their unique characteristic that pertains to all of them is that they all have a single electron in their outermost energy level. And that's going to be important for me talking about doing ionic and covalent bonding today. Okay. Now, once again, I'm going over this real basics of chemistry because it will help you understand and give you an idea of how the chemistry of living things works and why certain things happen the way they do. So, this is from yesterday's video. Remember that one square represents one element, and if you could take a sample of that element and keep dividing it and having it, when you got down to the smallest part that still had the properties of that element, you would have an atom. And to understand how atoms bond, we need to do a model of them, real crude models. So this number right here was 1 was the atomic number. It tells us the number of protons or electrons in that atom. This number here is a composite of, for practical purposes, protons and neutrons. So if we round this number to the nearest whole number, remember 4 and below, you round down to 1. There was a 5 here or a greater number, you would go up to 2. When you subtract this number from this number, it tells you the number of neutrons in an atom. And the nucleus of the atom is where the protons and neutrons are packed closely together. And remember, I told you I put a square there because if we use circles to represent orbits of electrons, then that first circle, it's like, okay, is that the nucleus or is that the first energy level? So I use a square. And remember that these things are three-dimensional. They're not two-dimensional, or they're not flat. They're three-dimensional. So if you had something spherical, then this is like a cloud. If the nucleus is like the Earth, then the electron cloud is like our atmosphere. Those electrons can move around the nucleus all the way around it. It's not just going in a little circle. It would be like floating through our atmosphere. Okay. So I diagrammed a lithium atom for you. 3 protons. Therefore, it has 3 electrons. The first energy level can hold up to 2, and you always start filling the energy level nearest the nucleus. You start with the first energy level. You work your way out. So if it has 3 electrons, you put 2 here. You have 1 left over, then it has to go in the second energy level. And atoms, when they form chemical bonds, they will transfer, take, or give away electrons to have whatever their outermost energy level is filled, or at least have 8 electrons there. 8 gives it stability. So they will share, transfer, or borrow electrons to have access to 8 electrons. Now that takes us into how atoms link together to form molecules or compounds. Remember, a molecule is the smallest part of a compound that retains the properties of that compound. So if you had a glass of water and you could extract one molecule of water, the smallest particle out of there that saw the properties of water, you would see a symbol, a model, something like this. That's H2O. That's what we use to diagram or model a water molecule. Now, this is a molecule because these lines here represent either electrons being transferred or electrons being shared, and that holds this whole unit together of 3 atoms. Remember, I told you that the number back here, the number following a symbol, tells you how many atoms there is. H2O, 2 atoms of hydrogen, and if there's not a number here, it's understood to be 1 atom of oxygen. So what I'm going to show you is how we get to this point, how the electrons are, for here, they're going to be shared. This is a covalent bond. Covalent. Because the electrons are sharing and they're dealing with the electrons in the outer energy level. And there's a special name attached to the electrons in the outermost energy level. They're called valence electrons. So therefore, when you have a covalent bond, it's atoms sharing electrons. They're valence electrons, which are the electrons in the outer energy level. Valence electrons are not anything different than the other electrons. It's just that we call the electrons in the outer energy level, they assign another name to them, and they call them valence electrons. So before we get to covalent bonding, I want to talk about ionic bonding. Okay. Pause. So chlorine is 35.4. So this means that chlorine has 17 protons, and it also has 17 electrons. This rounds to, sorry about that, that's my phone alert. All right. This is a 4, so it rounds down to 35. And this is, remember, is a total of protons and neutrons combined. So if we subtract the 17 protons, that leaves us with 18 neutrons. So now we want to diagram these atoms. Okay. So 17 protons or 17 electrons, 35 protons and neutrons combined. You subtract the 17 protons, you get 18 neutrons. So we're going to start with sodium, and I'm going to draw my square here for my nucleus, and it's going to have 11 protons or 11 positive charges, and it's going to have 12 neutrons with 12 neutral charges. And I also have 11 electrons to place. Now, I could draw the circle all the way around, but that gets kind of cluttered looking. So I'm just going to draw some half circles, and we're going to understand that this is like an atmosphere all the way around. So we have 11 electrons to place. I'm going to put 2 here. And remember that our second energy level can hold up to 8. 2, 8 is 10. So that means this is going to go out to the third energy level, which is going to have 1 more. Now, remember I said that in order to be stable, atoms like to have their outer energy level filled or with 8, okay? Third energy level can hold up to 18. So I doubt that it's going to take 17 electrons away from another atom. But if it gave one away, then this whole energy level would leave. The only reason it's there is that that electron moving in that space is defining it. So if you gave that electron away, that means the outermost layer then would be the second energy level. It would have 8 and it would stabilize that atom. But when it gives an electron away, it then has a charge because you have 11 positive charges, and before it gives it away, it has 11 negative charges. And so these each cancel each other out, so it's an overall charge, it's neutral. But it always keeps its protons, but if it gives an electron away, then it only has 10 electrons with 10 negative charges. And now you have an overall charge of +1. That's how it becomes a charged atom or an ion, an atom with a charge. When it gives away that electron, it loses the negative charge, so then it has an overall charge of +1. So you can already figure out where that electron is going to go. It's probably going to go over here to chlorine. So when I diagram chlorine, chlorine has 17 protons or 17 positive charges, has 18 neutrons, which are neutral. And now we need to place those 17 electrons. The first energy level fills up first. It will have 2 electrons. The second energy level has 8. 2, 8 is 10. And that means that the third energy level, which can hold up to 18, is going to have the other 7 to make 17 electrons. 2, 8, 7. Remember that the magic number is 8 again, which is called an octet. So the third energy level can hold 18 electrons, but since we're dealing with sodium and it's only willing to give away 1, we're not going to be able to attain the 18. However, if this 1 electron moves over here and the sodium is willing to let it go, because when it lets it go, it becomes more stable, having 8 electrons in its outer energy level. And this atom being bigger, it has a stronger positive pull because it has more protons, opposite charges attract. It can take that electron away from sodium. So when that electron moves over here, now you have access to 8 electrons, which stabilizes the chlorine atom. But when you talk about your charges, you still have 17 protons or 17 positive charges. And now you have 2, 8, 10, 17, 18 electrons, overall 18 negative charges. So now you have an overall charge of -1. So now you have a -1 chlorine ion. And opposite charges attract. So these ions, this chlorine ion and this sodium ion, will be attracted to one another and they will bond. And you will have a sodium chloride compound. All right. So when one is willing to give an electron away and another one is willing to take it, this here is an ionic bond because the resulting atoms end up with charges and then the opposite charges attract. Now, sometimes this may happen between 2 or 3 atoms too, okay? And this ionic bond tends basically to form between metals and nonmetals. So let me go back to the periodic table here. So I get back to here. Okay. All right. So back here on the periodic table, there's a little bit of the trends in the periodic table. I told you before, here's sodium. Column 1, all of these atoms here tend to have 1 electron in their highest energy level. This column over here are the noble gases. Column 8, except for helium. Helium has 2 electrons in its first energy level. It's filled, it's stable. The rest of these have